Some of the first studies were actually done in monkeys where you could record from neurons in the temporal lobe, and you could, if you presented a face that looked like this, you could see that, well, the spike activity in these areas of the temporal lobe, they increase. Also, if you present something that looks almost like a face, you will have it, but if you then remove certain features of the face so that it's no longer a representation of what you would call a face, well then you will see that the firing stops. But then again, if you have if you also have a box around it, then you will see that there is it's still recognized as something that looks like a face. And in the monkeys, it appears that the different types of facial gestures, they also give rise to increased firing. So these with the open mouth seem to increase the firing a lot in these neurons. And even the monkeys can recognize the facial expressions in humans. So it's not just species specific, it can actually also translate to other species that these areas, these are in the temporal lobe, they are able to recognize specific object features. Another study which has also looked at face perception, in this case it's in a situation where you have to, so it's like these illusions where you present an object, then you see a flash, and then you have to detect if something has changed in the image. And the task for the subject was then to determine whether the face had changed, or if it was a changed face. And if we look in the temporal lobe, you can actually see that the areas here in red, they show increased activation in the cases where subjects were not able to detect that there was a change, even though that there was a change. So it seems that at least some of the information about the face is processed in the temporal lobe, even though you don't necessarily consciously become aware of the fact that it has changed. So it seems that the temporal lobe is not, it can actually change activation and doesn't necessarily, this change in activation doesn't necessarily imply that you become consciously aware of it. I will, when we have the talk or the lecture on consciousness, I will show you what then happens when you actually become consciously aware of these changes. But at least some of the information that's related to changes in phases is represented in without you necessarily are consciously aware of it. Of course, also these illusions here, they will actually create, even though that there isn't a circle and there isn't a triangle anywhere, well then the contrast between these objects will actually give you an idea of that there is something in these object selective areas. And this is another type of visual illusion, and it's maybe a bit difficult to see, but you can actually, in some cases, see that there are some, it appears that there are some black dots in the area, in these crossing areas, even though that you, if you then try to fixate on them, then they will disappear, so they are a bit in the periphery. This is a phenomenon called binding, where the information about this direction selectivity is actually processed into something different, so you will get this illusion. Another feature could be color discrimination, orientation discrimination. So in this case, you have also parietal areas that process these different types of features, so and are able actually to locate them in the parietal lobe. So it's not just basic features in the primary visual cortices. Another feature which is quite interesting is also, as we saw with the motion sensitivity in the parietal areas, where you have both the air and the visual motion, and you have the auditory motion integrating in the parietal lobe. For instance, if you have certain types of stimuli that are tactile, auditory, and visual, you will also see that this area here in the superior temporal sulcus, so that's the upper part of the temporal lobe, just where the temporal lobe and the parietal lobe meets each other, you will actually see that there is an integration of all of these types of sensory incoming stimuli that will be integrated into one coherent feature. So now we have actually two different areas that are responsible for integrating common things about, in this case, the union of all of these activation or these stimuli. Also, if you present, for instance, an object and you present a corresponding sound, and you let subjects feel an object, so either you present a visual image of a dog, or you present an auditory sounding as a dog, or you have a tactile object that subjects can feel, you will actually see that each of these object presentations will activate, in this case, the areas here in the fusiform gyrus, so in the temporal lobe. And you will actually see that if you look at the overlapping activity between both the objects, the visual object and the auditory object and the tactile object, you will see that it's also integrated in these object selective areas in the temporal lobe. So, so you have several areas that are able to integrate information, and in this case, when it's an object, so that both have some visual features, they have some auditory features, and they have some tactile features, they will be integrated in these object selective areas in the temporal lobe.
Where's the three pictures next to the ducks?
So that's the control situation. So you have just a visual texture, so that's just noise image that you present, or you have a noise sound, or you have something like, yeah, it's the control situation that's shown here. So you see the difference between the the actual object and the control object. Another example of integration of many senses is a phenomenon called the McGurk effect, and it's a well-known multisensory integration illusion. And what you see in this example, and you can, if you Google it on YouTube, you will actually see some of the examples. It doesn't really work so well in me, but in others it's really good. But maybe it's also because I know what's the outcome of it. But you see a video of a person saying "ga ga," and then you hear a voice saying "ba ba," and what you then perceive when you have combined the visual impression of somebody saying "ga ga" and somebody hear, or you hear the sound of somebody saying "ba ba," you will actually experience, or at least a lot of people will experience the person saying "da da." If you then close your eyes and and you look at, and you don't see the person any longer, well then you will actually hear somebody saying "ba ba." And if you remove the sound and you just look at the visual image, you will actually see that it looks like somebody saying "ga ga." But in this case, these different incongruent situations will actually make you believe that something third is what's really the cause of it. Very recent study, which is actually almost not published yet, it just came out a couple of weeks ago, has actually shown that this superior temporal sulcus area, you can actually in that area detect how prone subjects are to actually experiencing the illusion. So the more activation you see in this area, you will actually see that subjects have more, they are more prone to experience this illusion. So this, one of these multisensory integration areas, the superior temporal sulcus, will actually give you information about or integrate these different visual impressions and sound impressions so that you will actually experience the illusion. Some also have claimed that if you're used to watching dubbed television, then this illusion will be less, because you're really used to just disregarding the mouth movements and then only listening to the sounds. So it probably works quite well in Danes, but probably not in Germans or other people who watch a lot of dubbed television. So